Hello there! We are the team number 1, made up of Pepe Galindo, Maru Garcia, Natalie Vargas, and myself, Rosangel Medrano. In today's lesson, we will talk about the stochastic counting process applied to the Italian soccer leagues in order to simulate the tournament expecting to get the most likely champion. Why soccer? The last year, we lived a pandemic that paralyzed the whole world. Such was the case that many sports did not have the possibility to finish their tournaments, and thus did not manage to get a champion. So we will take the Italian soccer to calculate a possible champion of the unfinished season, using historical descriptive statistical data, the Poisson computational process, and the weak law of large numbers. Using this information, a first histogram is made up showing the number of goals and the frequency with which they were scored during the tournament. This draws our attention to the following definition. The counting process definition says that we let 0 equal or less than t and t equal or less than 1 be an instant in time and nt be the number of the goals scored until the moment t of a football match. Therefore, we can say that the sequence of nt random variables with a t equal or greater than 0 is a counting process and fulfills these properties. With the above in mind, we can turn our thoughts to the best known counting process that is not based on the binomial distribution. The Poisson distribution will help us to simulate the scores of the tournament, taking into account the probabilities of each team to obtain a victory when facing each other team as a home or away team. Although it sounds quite confusing, we will show you how this simulation was carried out. So let's gonna watch this simulation in Visual Basic for the Italian leagues last season.
Hello everyone, I'm Natalie and I'm going to start talking to you about the basic instruments and statistics we use in this project. As Rose said, we are working with the A League from Italy. Well, first we have this table where we have our 20 teams. All of them will be playing 38 times, one on every jornada, and we will be counting all the goals they get in favor or against, and also if those were made when they were at home or if they were visitors. With this information, we were able to calculate the mean in favor and against of goals by minute in here. And also the lambda, which in this case will be our binomial expected value, like in here. All these for the cases where they are at home and when they are visitors. In here, we only have the total of goals in general for every team. Then we have a table only with the favor goals of each team and calculated the mean by match and by minute. By match and by minute. We also have this big table with all of the goals made by every match last year. And we were able to have a mean by match and by minute in general for the whole league. In here. We use this general mean by minute to calculate the empiric, the binomial, and the Poisson distribution. We stop at 12, but in theory we could do much more. It's just that these numbers in here and in here are very, very small. As we wrote in here, we also took the number of goals made in every match from the big table to make this little one in here. As we can see, it stops at 9. And we made 2 histograms, one comparing the 3 methods above and one with this table. And we can see they are practically the same.
Hello, I am Maru. Thanks to Rose and Natalie, now we have all the theoretical tools to create this beautiful program. Who wouldn't like to know the chances in percentage each team has in a match? Let's get started. First of all, we need to put in order all the ideas that Natalie and Rose have. First, we need the number of matches at home each team has, the goals for at home, goals against, matches away, and goals against away. Then we use the theorem that it was about a random variable with binomial distribution and parameters n, comma, lambda t over n in order to estimate these probabilities. Is 0.5 chances plus the Atlanta has and goes against away. In this case, the visitor is Bologna, which is this over this. Then we made this beautiful table that looks kind of monstrous at the beginning, but it would be useful. Now we present you the code. First of all, we need this public function called fish in this case, because it makes reference to the Poisson. We declare U, P, F, and K. Then we create a random number, and then we made this operation in order to make this easier, which is to obtain the inverse function. This will be used in the following code for the Italian league. Now, are you ready to know who would win? Perfect. First, we ask the user to give us the number of the team as a home and the number of a team as a visitor, and then the number of simulations required by the user in order to make this estimation. Then we estimate the lambda taken by the table shown before. And then we made it into 0 in order to start. As you can see, we use this process showed at the beginning of the presentation in the public function called fish. Then in each row, it counts the number of ties of wins of each home and visitors. Then we need the frequency. So the frequency is the number of matches they win, as a visitor, as a home, and a tie, and we divide it into the number of simulations the user gave us. And then it is printed on the code. So let's use it. Now we are ready to start. We push the button and then it asks us the number of the team home. We will choose Parma as a 14 and the visitor Nápoles. Then we ask the program for 1,000 simulations. And there we can see that the home has 37% probability of winning and the visitor has 42 chances of winning, and there is a probability of 22% of a tie. Now let's play each time you want.
Hi, I am Pepe, thanks to all my teammates. I will now explain the last part of our simulation. First, I want to come back here to this huge chart that has every combination of games with each team playing at home and away. The numbers you can see are the lambdas that will aid us whenever we want to model a single game or even the whole league. For the whole simulation, which is a big problem, as said, we aided ourselves on Captain Subasa's PDF, made by Dr. Daniel Lopez Barrientos, Dr. Enrique Lemus, and Dr. Eliud Silva. And for the simulation of the whole league, and to finally know who were the most likely to win the cup, we were said that it was really busy work, and it was a valuable exercise for the interested readers. Luckily for us, we were not interested enough to fit said category. Yet since we are good people, we're gonna show you our approach to get the winner of the league. This is the code we used. It's called Code Awards, and it uses basically the same principle that is used in the Italian league, but we needed two numbers to count, I and J, that will help us to make 2 cycles with 4, and the W is just to help us print. And what we did was to skip whenever the team was going to play with itself, it skips to the next one. So it models the games of team 1 versus team 2, team 1 versus team 3, team 1 versus team 4, and like that. We did 10,000 simulations for each, which was the requirement. And basically, this is all we needed to know in our simulation. So here we can see home wins, the away wins, and the ties, the probability to get a tie. This is just simulated here. How likely is it to win each game? To know the winners, we started and we wait for a little while because we have 10,000 rounds.
3:28 a.m.
Okay, now we're back. We finished. This chart is basically how likely each team is to win the game. The home team, the away team, or for them to tie. And here we have printed which team we're talking about. The team number 1 or team number 2, team number 1 versus 12. And like that, it goes in order. We can see clearly the 4 cycle here, the double 4 cycles. And this is the result of every single of the 380 games. We come down here, and it's pretty noticeable. Considering that this is not a tournament with disqualifications, like the World Cup or something, and that the most important thing is to win the most games as humanely possible, we figured that making an average on the probability on each team winning their games, being those at home and away the same number of games, 19 and 18, this will allow us to know how likely it is for the team to win any one of the 38 games. So this is the little formula we came up with. If we didn't find the said team here on top, on here, we would search for it on here and take the probability on the right or the left, depending of if it was on the home place or away place. And well, to see the final results, well, almost the final results. Here we can see finally how likely each team is to win each game they play. So if they play 38 games, in each of every those games, the first team is 54% likely to win the game. Doesn't matter with who, just because we made an average, that's what it makes. And we did that for the 20 of them, which is a pretty cool graph, actually. And with different, we use the button sometimes, and the top 5 were the one in column I, P, Q, S, and T. Here, finally, we checked the top 5 that we saw down there that were highlighted. And these 5, Internazionale, Milan, Atalanta, Juventus, and Lecce, were the top 5 in most of our simulations and were handpicked by all of us. At the right of it all, we can see Internazionale in a deep black. This one is automatic and tells us the most likely winner of the tournament by using different ifs and maximum functions that are built in Excel, just taking in account the last line of everything here. So yeah, that's how we got our winner. And that's all.
And ciao. Thanks for watching and see you in the next video. We hope you enjoyed it.